Hello, my name is Jo Boaler and I'm the Nominelli Olivier Professor of Education at Stanford University. I'm British, I live in California now, but I started my academic career at King's College London. I moved to Stanford and then I was at Sussex University for a while and now back at Stanford. And as this conference is about educational innovation, I thought I would share with you a really important innovation that I believe is really important for humanity. So I'm going to start sharing my screen. I won't be presenting research as much as I'll be sharing this new initiative. And we're calling it a data revolution. And I'm actually in partnership in this initiative with Steve Levitt, who is an economist, wrote Freakonomics. But I'm also working on this initiative through my center at Stanford, which is called UCubed. If you haven't been to the center, it's really to generate lots of important resources around mathematics, teaching and learning. If you'd like to follow up on any of the ideas I'm sharing, I have a couple of books, one written for maths teachers and one written for teachers of any subject, or actually not only teachers, but anybody. But I'm going to present today on why it's so important that we bring data science more centrally into K-12 education. So this statistic is a very interesting one. 90% of the world's data has been collected in the last 2 years, just telling us about the importance of the time we're in right now, in this data-filled world that we live in, and how important it is that we help students develop data literacy. We have developed a picture book you can find on UCubed to help students get the ideas of the importance of data science and also help them become data literate. All of our young people now are giving away their data with all of the apps they use, and we think it's important that students become more aware of that. Data science is not the same as statistics. I think, unfortunately, it doesn't have to be like this, but in many schools, statistics is taught as a set of methods to learn, whereas data science starts with real data sets. Students are using data, hopefully from their own community, which helps them feel a sense of community belonging. And they have more open discussions where there isn't one right answer. And they're also learning a bit of coding, they're learning to use technology. Data science is a naturally cross-curricular subject. I'm very passionate about bringing it into mathematics, but we could think about ways that any subject teacher could bring data more centrally into their teaching. And I love that data science is beginning now as a field in a very inclusive way. It's being presented as a subject that anybody can learn, unlike the way mathematics has been presented over the years. So I thought I'd share by sharing a little video that comes from Stanford, from the women in data science movement who are really passionate about keeping data science as an equitable subject.
Data science can be found everywhere, shaking up almost every aspect of our daily lives. But most people really hadn't heard of it until about 10 years ago. It's one of the fastest growing fields today, so there's a ton of opportunities for everyone to be involved. Anyways, what is data science? In a nutshell, data science combines data collection from sources like social media and satellite images, faster and cheaper computer systems, foundational math and statistics, and data visualization. Together, these things give us helpful information for making decisions and tools to make our world a better place. Now, imagine you're relaxing at home and you've just finished rewatching the series finale of your favorite show. Whatever will you watch now that it's over? The fact that your streaming service keeps suggesting teen dramas isn't a coincidence. As you can probably imagine, data science can be used to solve other bigger real-world problems. It's a field that requires constant collaboration amongst people with a variety of backgrounds and expertise. Diversity and teamwork are essential, particularly when data is used to help tackle big challenges like healthcare or food or energy supplies. Having a broad set of perspectives helps us avoid bias and other unintended consequences.
So you can find more of that really interesting video from their website. But in the US and in many countries in the world, one maths pathway has dominated teaching for generations. And that is a pathway to calculus. And in fact, the current sequence of courses in the US, Algebra, Geometry, Algebra 2, was created in the 1800s, and it was created to help prepare students for calculus. But if we look at the proportion of students in the US who actually get to calculus, it's a tiny proportion. And I really think we should question, are we teaching students the right mathematics? I organized a data science conference at Stanford in February of this year and invited Conrad Wolfram, who is one of the leaders of Wolfram Alpha, a really important mathematician. And I want to share with you a little video of his presentation on the day, which I think really helps us think about the mathematics we're teaching in schools.
Right, but if you're talking about the math subject that you deem is important for everyone to learn, I would say that you have to conclude in the end that that's the purpose of it. So here's a typical example that I love to show about where computation, in a sense, and doing things by hand can work differently from conceptual understanding. So here's a simple equation that basically everybody has to learn how to solve by hand at school. But you see, it's very strange because when you, for example, put a simple change to that in this, you get a slightly more complicated answer. And this is one that people typically don't learn how to do after years of schooling. And in fact, it gets slightly worse than this, because if I talk to my phone and I say, solve x cubed plus 2 equals 2y and y minus x equals 5, Siri willing. Okay, so it's actually done a numerical result for some reason, but you can see that it's gone and computed this and even done a nice little plot of what it's done and so forth from alpha going through Siri. I'm going to shut it up there. So the question you've got to ask is, if I can talk to my phone in 20 seconds and get an answer to a question that most students after 10 years of study cannot answer, why the hell are we getting them to do that and not something different that empowers them further and doesn't do something that the computer can do much better than them?
That full presentation is on YouTube. So how did I get involved in this data science movement? I actually received a phone call from somebody, a little unusual for me, not in education, not in mathematics. His name is Steve Levitt. He's an economist, as I mentioned. He wrote for economics. And he asked me, will you help me try and change high school mathematics? And I said, absolutely yes. So he put together this advocacy group, some pretty important and influential people on the group. And there was also a really interesting Freakonomics episode about the need to change mathematics worldwide, and you can access that. But here you see some really interesting data. This is the proportion of high school courses schools in the students in the United States are in. And you can see very clearly from this data set that the majority of students don't reach calculus. So we really have to ask the question, not only Conrad's question is the mathematics outdated, but are we even teaching the right mathematics? The people in the Freakonomics put out a survey on their website. They have about 8 million people on their website, and asked them, what maths do you use in your everyday life? And this graph is just showing the results of what most people answered, which is the daily and the never categories. And I think you'll see pretty clearly a very big emphasis on data, and not many people saying that they're using the maths that's emphasized in schools. They were a bit worried that their Freakonomics group is highly professional, skewed towards men. So I repeated this survey with a group of education leaders in California and got these results. I'll put both survey results side by side, and you'll see very similar results. So I think the question of how can we update the mathematics students are learning is very important. In February, I invited a group of people to Stanford to discuss this issue of, are we teaching the right mathematics? And I started off by inviting the open-minded mathematicians I know. Steve Strogatz came over from Cornell, Conrad Wolfram flew in from England, Talithia Williams, lots of great mathematicians. But then more people wanted to come, so we ended up having data scientists and policymakers and all sorts of leaders. Stanford released a press release from the event that I want to share with you, a video from this press release.
We know that the mathematics curriculum that's currently in schools, the maths that students are learning, is really outdated. The world has changed dramatically in recent years, yet our maths curriculum has stayed the same. And in fact, the sequence of high school courses that are in the US, algebra, geometry, was actually created in the 1800s, which is kind of mind-blowing. So we really urgently need to teach kids the maths they're actually going to use in their lives and work and courses.
I believe data science really opens up, both within math classes, but more broadly within education, ways for children to become the discoverers of knowledge as opposed to the recipients of the brilliance of past generations. So at a very practical level, data science is useful because data science is increasingly becoming part of what you do.
We really need to get mathematicians at the table if we're going to change high school maths. So it started off with inviting about 10 mathematicians to come today at Stanford. We ended up having data scientists, there are high school teachers, and policymakers are here, people from the universities are here. So we've really brought together those people that we think can make this movement happen.
This is a rare opportunity to gather with experts, other educators, researchers to discuss what is it going to really take to make data science education accessible and valuable for students.
It's a very exciting group that's been put together, and I think it shows tremendous promise for being able to actually spearhead a change. This change will happen. I think the opportunity is to make it happen in the best way possible, enfranchising the largest number of people as we go.
I believe that all of us need to know how to look at data, how to understand data, and to have the expertise to work in the modern economy. So much of every person's job in the future is going to involve some aspect of data, as we've seen data explode in terms of how it's being collected and how it's being used. I really think this is such an incredible opportunity to bring people together to make this change in the education system.
This really seems to have the potential to change the maths in school, change it from a very procedural, meaningless subject for most kids into something that they can see is useful in the world and feel empowered to use that mathematics in the world.
There are some really interesting initiatives already happening. The new SAT, which may not survive in the current climate, but they had shifted to make 20% of the questions be data analysis. LA Unified, one of the largest school districts in California, designed an introduction to data science course a couple of years ago. Thousands of students have already taken it, and it's very successful. Many college majors courses require statistics and data science, actually more than require calculus. And so I think we should start to recognize that. And I'm also working with Stanford at the moment to change their admissions statement so that it doesn't lay out that it really just wants kids working to calculus, but really acknowledges we could have different pathways in schools, such as a pathway in data science. The University of California has already issued a statement saying statistics is really important, but those ideas are not really impacting schools enough yet. I am one of the writers of a new framework that's going out in California in 2021, and that in that framework we are going to highlight data science as one of the most important areas mathematically. I'm also excited about the equity implications of a data science pathway. Sadly, calculus is a very inequitable pathway in the United States. Often students are filtered into different pathways in 6th grade. when they're sort of 11 or 12, and from that point it's decided who can get to calculus. So there seems to be a lot wrong with that, and we hope that when data science comes out more widely, it will be an equitable pathway. It will be, all students will be invited into it. I wanted to share some resources. My center at Stanford, in collaboration with Google, is writing at the moment a new high school one-year data science course. It's going to incorporate free tools such as Google and encourage teachers to bring in their own data sets so students can work on their own data in their own communities. We have other resources that are there too. I have a new online class that's introducing teachers to data science and teaching. We opened it in July. We've already had over 13,000 teachers are inside the course. You can find all of this on YouCubed. We have units of really exciting data science work that are sort of grades 6 to 10. And an initiative we're starting is the idea of all teachers of any subject area starting their lessons with what we're calling a data talk. So the New York Times every week highlights a really interesting data visualization and asks these great questions. What do you notice? What do you wonder? What's going on in this graph? Not closed questions, but open questions that invite students to share their thinking. And many different kinds of data visualizations can be used. This is one of the ones I like. You just put it up in front of students and ask them, what do you notice? What's interesting to you? So there's quite a lot going on in this graph about dogs. As we can see, there's 4 axes. There's 4 quadrants rather, 2 different axes. It's somewhat complicated. We can have data visualizations like this. We can have more complicated ones that require higher degrees of data literacy that may be great with older students. A graph like this, for example, is more appropriate for older students. There's a lot for them to see and think about. So the idea of a data talk is you just put it up in front of students and ask them, what do you notice? And then have a discussion with them. You could bring in all sorts of different subject areas. We could use data visualizations with kindergartners and first graders that require them to interpret, but not at such high levels of data literacy. This is a graph that's showing us the percentage of the population in the world that's undernourished. As you'll notice, some of these data visualizations don't really have a lot of numbers, but still extremely important. This is a data visualization that's inside my online class that's taken from the Pew Center and gives a couple of different ways of thinking about data on books people have read. So I'll just finish by saying we have lots of resources on our website. We invite you to have a look and think about bringing data science. If you're a leader of education, helping teachers become aware of the importance of this new form of knowledge that we need in the 21st century. If you're a teacher yourself, thinking about ways of bringing data into your teaching. This, as I mentioned at the beginning, seems to me to be our moral imperative as we send our students out into this newly data-filled world. So I hope I've left you with some interesting things to think about. Come to youcubed.org to see more. Thank you very much.